Hi again, folks. This video I'd like to look at theorem 7.3 again, corollary number 2, this time using similar right triangles that we've been working with, divided with an altitude, just like in the last videos, divided with an altitude to the hypotenuse, intersects there at a right angle. This is also a right triangle. And corollary 2, again, not important that you remember what it's called, but it is important that you remember how to use it. Corollary 2 is going to relate the segments of the hypotenuse, so maybe this segment is blue, this segment of the hypotenuse is blue, and let's say this segment is green. So we can take the hypotenuse, the altitude divided the hypotenuse into two pieces, and those pieces are related to the side that's next to them. So maybe this side here in light green, that's the side, this leg is adjacent, next to, touching, next to, adjacent to this segment. And similarly, maybe get a light blue here. Light blue on this bottom side here, this leg on the bottom of the triangle is related to that segment and the whole hypotenuse. So let's just write out really quickly in words what corollary 2 is saying. So let's call this segment 1. And if that's segment 1, then it's next to its adjacent leg. Let's call that leg 1. Leg 1. So we can say that segment 1 is related to leg 1. Segment 1 is related to leg 1. So segment 1, again, that's segment of the hypotenuse. Segment 1 is to this adjacent leg. Okay, and here, this leg is adjacent to this section, this segment. They touch. Okay, so these two are adjacent. They're next to one another. Okay, and that adjacent leg is the geometric mean. So I'll say this is the adjacent leg again. Adjacent leg is the geometric mean between segment 1 and the whole, and this is the key point here in corollary 2, whole hypotenuse. So here, that would be this blue section here plus the green section here. So this would be the whole hypotenuse is what the segment is related to. How is it related? Well, the geometric mean between those two values is this leg right here. I could do the same thing for the other segment. I can say that this leg here, so call this leg 2, and how about this is then segment 2. Segment 2. I can say then that's segment 2, the green segment 2, is to the leg 2 as the leg 2, the second leg here, second leg 2, adjacent leg 2 is again to the whole hypotenuse. So the trick here is identifying the correct leg, and all you need to really remember is that you always use the leg that's touching the section you're trying to find. So if I want to find this segment, segment 2, I want to use this leg that's touching it. If I want to find this segment, the geometric mean, the one I want to use is this leg, the one that's touching it there. Let's look at a quick example of how you might set one of these up. So say I had this triangle here, and they gave me an altitude. I'm going to still do that in red. Altitude. And let's say that they gave me that this side here, this is the variable I want to solve for. And they told me that my first segment, say this is 4. That segment is 4, And this segment down here, this is 6. Well, what I would say then is that this leg is the geometric mean between 4 and 4 plus 6, or 10. Okay, so I could say that 4 was to x as x was to 4 plus 6. And that's the whole hypotenuse. 4 plus 6 is the whole hypotenuse. So the segment here is 4, this segment, this top segment, is to the adjacent leg. This leg is adjacent to this segment, so that's x, as the leg, the adjacent leg, again, that's the geometric mean, is the leg is to the whole hypotenuse, 4 plus 6. So that's how I'd set that up. And I could continue this, I could go through here, and I could say that this means 4 over x is equal to x over, well, 4 plus 6, that's 10. And then I could just solve that way. Now, one other way that you'll see this is, what if you had, say, another triangle. You had the triangle here, and they didn't give you the segment, but they gave you the leg. Well, okay, so here's my altitude. Say that my segment now, say that that is x. Say my leg, this leg on this side is 12. And they told me that the whole hypotenuse maybe is, I don't know, 17. Okay. Well, I still set up the same way. I'd still say that this segment x would be to the leg 12, the adjacent leg, as 12 would be to, well, now that's the whole hypotenuse, so that would be 17. Notice that this is a little bit different from the last setup in that my variable only shows up once. I'm not going to get a squared term, but that's okay. I still plug them in to the corresponding positions. This is still the segment. This is still the segment on top here. This is still the adjacent leg. The adjacent leg is still the geometric mean, and in this case, that's the one that shows up twice in the proportion. And then the whole hypotenuse, 17, well, that's still 17. So just to solve this out, now that it's set up, pretty straightforward. 12 times 12, 144, is equal to 17x. 17x, and then I just want to divide by 17. Divide by 17. So I'll say then that x is equal to 144 divided by 17. 17 is prime, so that's not going to reduce. And I'm just going to leave my answer just like that.